I'm going to go ahead and finish up this presentation. We were talking about the assumptions with mutant testing. First off, we do assume that in general programmers are competent, and in general they talk about, or coders like to go along the happy path, assuming inputs are what they expect. So mutant testing can definitely help out finding certain bugs, because your users a lot of times are just going to look like they put in random inputs, especially if some of your users are kids, and mutant testing can help you find a lot of those. Another hypothesis or assumption we make is that any simple fault will usually lead to more complex faults. And this should be at least somewhat intuitive that this makes sense, because a lot of times if you're off by one, that can triculate the problem, although that's not necessarily all the case. But even if mutants are not a perfect representation of real faults, you're just getting a good ballpark idea, or giving yourself confidence that your test suite is effective. So what are some things that mutants can do? Well, you really want to keep them simple syntactical changes from the legal program, so it's still a legal C++, Java, or JavaScript program, but you want to make it simple so it's easy to spot and figure out what your test suite is missing. For example, you can do constant replacement, so instead of x less is 5, you could replace it with x is less than 12. Or you can do some type of relational operator, less than equals goes to less than, or you can do greater than. Another one is operations. Maybe you could change it from a plus to a minus. There's a whole slew of very simple things you can change, and also there's programs out there that can actually automate that for you if you need help with that. Another one is just changing the initialization or eliminating it altogether. Instead of x equals 5, it's just x, and then seeing what happens next. Okay, so live mutants, let's say we create 100 for our program, we run the test, plus the original. The original program, of course, passes all our test cases. 94 mutants are killed, so fail at least one test case. That actually gives us a lot of confidence that our test suite is capturing a lot of the issues. But 6 mutants are still alive, aka the test suite should have killed them, but it didn't, so it missed a couple of mutants. What can we learn from these mutants? Well, maybe there's something we can do to edit or change our test suite. Obviously, going in, maybe there's something you can change. But first off, do keep in mind that sometimes it's not necessarily a fault, because it may be in your program that doing x is less than 0 or x is less than or equal to 0 doesn't change the output at all, or really change your functions of your program. Maybe you're just doing fewer computations if you do x is less than 0 than if you do an extra computation for if it's less than or equal to 0. So it's not so much a fault, and in this case, determining whether the mutant is equivalent may be easy or hard, and of course, in the worst case, is undecidable because, of course, the halting problem. Or your test suite could be inadequate, which is actually kind of a good thing, because now you know exactly what you need to change for it, and now you've figured out during mutant testing as opposed to user testing. So then you can go ahead and change the test suite. Now, so I've talked a bit about mutants. One thing I want to make sure before I go on to the last two characteristics of mutant testing is that for your program, since you're probably doing a small, or for your project, your classroom project, since you're probably doing a small piece of code, you want to go ahead and do the mutant testing manually by creating copies of your unit code, adding a change, maybe equivalence change, or changing a constant from 5 to 10, and then running down your test suite. 100 different mutants is probably not a bad number, although that might be a little high for some of y'all, so maybe 50 would be good as well. And then go ahead and do that test and see if your test suite catches all of them. On the other hand, if you go online and you just simply Google different test suites, there are plenty out there. I just Googled mutant testing C++, good old Stack Overflow, and immediately I came up with 3 answers for C++. And that's just another tool that you plug in your C++ code in, and it gives you mutant testing, non-zero to, and if you look at here, the 2 lines of code, all they changed is sum from plus to minus. All right, that one probably won't cause many issues, but maybe that less than or equal to size might as well. So there's different mutants that it could pop up with. In Java, they have one as well. PIT, state-of-the-art mutant testing system for testing Java and the JVM. So there are tools out there that will automate a lot of these changes for you because they'll do static analysis and then spit out new programs. So you could plug in one of those if you feel so inclined as well. All right. So lastly, before we finish up, I want to talk about different variations of mutants. And this has to do with the fact that sometimes mutant testing can be very difficult to complete because, for example, maybe there's too many mutants you need to test and running each test case is it too expensive. Maybe it takes too much time, like it won't complete within a month, so you need to trim it down. Or maybe every time you run the test, it costs the company a certain amount of money. Maybe you're using a very expensive cloud service, or you actually have to run a piece of hardware that's very expensive to maintain. There could be a whole slew of good reasons for this. So what you do instead is you execute what's called a metamutant, which has many seeded faults. So remember, beforehand, each mutant only had one bug in it. Now we're going to do a metamutant, which has multiple bugs inside of one program. And then mark the seed fault as killed as soon as the difference is found, without waiting for the program to complete. Restart with a new mutant selection after the kill. So the idea here is that maybe you can quickly find a collection of mutants that aren't working, and hopefully narrow it down that way. Another one's statistical. Of course, again, there's a lot of mutants. Beforehand, there's a lot of mutants. Now again, there's still too many mutants. Maybe it's too expensive to run everyone, so just create a random sampling of mutants. So beforehand, we combine them, and the statistical ones, we just pick them at random. Maybe every time you run your mutant testing framework, you choose a different sampling of mutants to come from, and then you run that. Obviously, you're not going to probably find every single test case, but hopefully by a random sampling, you'll still get a good ballpark figure of how well your test suite is testing your program. And I believe that's all. Oh, back in real life. Okay. One last feature before we continue on. Most of y'all who've done testing probably have not done mutant testing. And that makes sense. I understand that. Because most of the time with mutant testing, they're really good for any type of manufacturing or any type of really like life-saving devices as well, because mutant testing usually is a little more expensive, but it is also a lot more thorough in what's going on. So for manufacturing, remember with hardware, once there's a problem with hardware, you can't just go up there and upload a change. You would have to replace all the hardware. So having a warranty on hardware is actually expensive, so they need to do mutant testing to give you a better idea of your test suite. Also, if it's a device, keeping someone's heart beating, you probably wouldn't do mutant testing as well to give you even more confidence it's working. If you're developing an app on Android, you're probably not going to be doing much mutant testing, because if there's a problem, the user tells you, and hopefully you just upload a new change, or maybe the bug actually doesn't even matter to begin with. So that's why the point here is not widely used in industry, but it does play a very significant role in research, and it is actually a very important tool for when the program you're working under requires a higher confidence in your test suite. So some use of fault models to design test cases is important and widely practiced. All right, I think that concludes it. Oh, not quite. So bugs were marbles, right? We get, just going back to the analogy of, you could put some nice black marbles to judge the quality of test suites. Bugs aren't marbles. Mutant testing may have some trouble assumptions about seeded faults. The analogy, all it's trying to say here is the analogy of our bag with black marbles isn't perfect, but it gives you a good idea of what's going on. Nonetheless, mutant testing is going to give you a good ballpark figure about how your test suite's working. If you're getting 94 out of 100, your test suite's definitely on the good end. If you're only getting 20 out of 100, your test suite's definitely not on the good end. And then you have different variants in between. All right, so that's all for fault-based testing. Have a good weekend.